Up on stage, we have Joyce Chen from Thomson Reuters, who's going to be moderating, John Walport from IBM, Global Blockchain Offering Director, and Kelly Olson from Intel, who's heading up the distributed ledger technology there. So part of what we're going to do here is explore what, the perspective on blockchains in the future from enterprise giants. So let's get back on schedule, and I'll let Joyce take over this one.
Thanks, Louis. Joy Shen from Thomson Reuters, part of the emerging technology team. And why don't we do a quick introduction, and then we dive into the questions. John.
Hi, I'm John Walpert. I'm the director of blockchain technology for or offerings for IBM. And that's me.
And I'm Kelly Olson. I'm in the new technology group at Intel, and I lead up a team on distributed ledger.
And we originally were going to have Microsoft as well on the panel, but due to late night weather last night, they couldn't make it. So anyone from Microsoft in the audience, if you want to chime in, just feel free to shout here. So this panel is a little bit different, or at least it tends to be a little bit different, to talk about enterprise technology giants' view in blockchain or distributed ledger, and why you are all excited, in addition to a lot of the ecosystem activities out there from the startups, the financial services firms, and other stakeholders in the ecosystem. So to start with, from Thomson Reuters, we kind of see how the different market players are moving. And Microsoft, it seems like, is taking a somewhat different approach. They're partnering a lot with different startups, right? Ethereum is on Azure, and they just keep announcing different small partnerships with startups and trying to do kind of a blockchain as a service on their marketplace. At least that's what they talked about in their blog about a couple of weeks ago. So tell us about what is IBM doing, what's your approach, and similarly with Intel.
Okay, so hi everybody. So IBM, we've been working for quite a while on blockchain technology and distributed ledgers, and we've been working in Ethereum and Bitcoin itself, and Iris and Stellar and Ripple and all that stuff. We learned a whole lot, and we just said, our clients were looking for a set of requirements that we weren't seeing well handled in any of those particular fabrics. So that's why we got behind the HyperLedger project with the Linux Foundation. So that's sort of our strategy, is to really go all in on that and make sure that is, we focus on that. So what we're doing with, and so you might have seen, we just put out on our cloud, our version, so Bluemix, you might have seen that we put out IBM Blockchain, which is a fork of that work. And we will deprecate that work as the HyperLedger stuff comes online later this year, and basically run it on HyperLedger as that comes out in the next couple months. So that's so our cloud strategy is behind that. But of course, you can, just like Azure, you can run any of these loads, right? Ethereum, Ripple, you can run any of these things on IBM Cloud today. It's not hard. So I guess we also have that. But we're really behind the HyperLedger thing.
So let's talk about HyperLedger a little bit later. But what about Intel? So given kind of where Intel plays in the technology stack, how do you kind of view you guys self in this?
Yeah, so I think we've taken a bit more of a research-oriented perspective. So we got involved in this space a couple years ago, and similarly looked at things like Bitcoin and Ethereum, and also tried to look at some of these new use cases that people were talking about, whether it be for supply chain management or financial services or IoT. And as John said, really when you start trying to map those requirements to the technology that was out there at the time, there were a lot of issues, and in particular around scalability and privacy. And what we've been working on over the past year and a half or so is an open source fabric that can be this underlying blockchain infrastructure. So similarly, we're part of the HyperLedger Foundation, and we're trying to research some of the tough problems of distributed consensus in distributed systems, such as scalability. So how can we do hundreds of transactions per second with thousands of nodes? Because I think that's really the innovation that is behind, or that people saw with Bitcoin. And I think what we're seeing in the space right now is a little bit of a mix between looking at that innovation of Bitcoin, and then also turning back to some of the concepts in distributed systems that came out in the past 10 or 15 years.
So you talked about performance, right? And one company before this, Tendermint, talked about their performance compared to Ethereum and others. So kind of unpack that a little bit for the audience here. What specific kind of assets that you guys are thinking about from an Intel perspective and from an IBM perspective? And with your perspective with enterprise use cases, what kind of things are you guys doing to improve that performance, or what does that trajectory look like?
Yeah, so I think for us, one of the things that you'll learn about Bitcoin and blockchain as you get into it is that a lot of the bottleneck is around the networking side. And so you're seeing a lot of this today with the Bitcoin block size debate. And one of the real innovations of Bitcoin and the consensus mechanism versus traditional distributed database technologies is that it's actually a lot less bandwidth intensive. And so what we're trying to do is bring the same sort of scalability characteristics that you get with proof of work without all of the electrical consumption. So we're looking at how do we improve the performance by unique processor features that we have, and also accelerate things like encryption and signature verification and those sort of things. So we're looking really down at the hardware level. What are the assets that we have there that can make these systems more performant?
Great. And then John, you talk about kind of HyperLedger. So talk about that. Intel, IBM, and many other large tech companies, you guys are involved with R3, right, which is a separate consortium, made announcements, again, 3 days ago about how they are working with different banks, and both of you are involved. And HyperLedger, again, you're there in the party as well. So talk to us about Linux Foundation, HyperLedger. How does that differentiate from the existing offerings today? What's the strategy? How do you build that community?
So one of the things that's really important about the HyperLedger work is that we recognize that, I mean, most of the fabrics that are out there today are open source, right? So that, I mean, you can GPL or what have you, they're open source. You can get the source code. But that, we didn't think that cut it well enough, right? What we needed to see was open governance and open innovation. That is, if IBM, if we came up with a fabric on our own and open sourced it, well, Intel's doing the same thing. They're going to do the same thing. We're going to have all this stuff. It's going to be balkanized. And we said that's kind of madness at the lowest level, right? At higher levels, like consensus itself. Consensus isn't part of the HyperLedger specification, right? It is above that because lots of companies should be able to compete at that level, right? And so if the fabric itself, the standard, encompassed too much, then it wouldn't be a very good standard, right? It would be sort of like IP or most of layer 7 today, right? You want that stuff low level, basic, so you don't have to rewrite it. And that's what Bitcoin and Ethereum and all the other existing systems had to do. They're not really fabrics. They are full stack. They are applications on top of platforms on top of fabric. And we said, no, let's get the fabric done cross-industry. Let's get all the smartest people together from across industry. And it turns out that none of us really want to have to do any of this work alone. Right, so let's get that into a Linux Foundation, and let's all back out of it and say, look, we're not going to control it. They're not going to control it. It's kind of like blockchain itself. We're all in control, but none of us are controlling. So that's what the HyperLedger project is all about: is to get those basic things, like how a consensus algorithm plugs into the fabric. How does that protocol work? Things like that. How do you do logic on a blockchain? How is that modular? We like the idea, for example, that you should be able to write it in any language and containerize it, but maybe somebody else in the community likes a different approach. Those things need to be contained down there in the basement. And that's what HyperLedger is all about. So it doesn't really compete with the application stacks that you might see, right? It's not about Bitcoin. In fact, if it's done right, you could build a Bitcoin on top of it. If it's done right, you can build an Ethereum on top of it. If you could go back in time and say to the guys, to Vitalik, you say, why do you want to write all this stuff, man? It's just write the good stuff above it. That's what HyperLedger is about.
Anything to add, Kelly?
No, I think that's a good classification. I think the nice thing about the HyperLedger project is it's bringing tech companies together with some of those in the financial services. So for instance, we're seeing folks like JP Morgan that are building their own infrastructure as well in blockchain. And I think, as John said, there should be a unified, at least, framework on which to build these blockchains. So some core fundamental building blocks that people shouldn't be re-architecting and reinventing the wheel every time that they want to deploy a blockchain.
So we'll come back to the fabric part later. But talk to us about R3, right? Because that's kind of the little bit mysterious to a lot of people. Lots of activities, lots of consortiums out there. There are new ones forming. So from a technology player's perspective, are you contributing your technology? Are you experimenting with the banks? What are you doing there?
Yeah, so just last week we had a press release that went out that talked about R3, 40 of their member banks working with both Intel and IBM technologies. As someone in the business incubation group at Intel, I really like and appreciate the approach that R3 is taking, which is a customer-centric approach, right? And so you can build the best technology with all the bells and whistles that you want, but if it's not meeting someone's needs and their requirements, then it's kind of a worthless effort. And so we really appreciate the approach that R3 is taking because if these things are going to have the impact that people talk about, you're going to need multiple banks participating together, and they're going to need to work to solve some of these things like regulatory issues.
What he said, I mean, we really dig those guys. The R3 team is very good. I mean, but all of them are. DAH is awesome. They're all doing different things in different ways. Right now, what we see R3 doing is bringing us together and being one of the most active consortia, right? When you hear the word consortia, you do not think about speed, right? But these guys are moving pretty quick and doing stuff. They're not just sitting around. They're doing projects, and they came to us and said, like you guys, and said, hey, can you do this thing and show us what you're capable of doing on this particular use case? And we stepped up and did it, right? And so did you guys, and some other companies did as well. And that they were able to all use that, try it out, evaluate, and then give us their feedback. So that's a good start. I should say HyperLedger is not a consortium, right? It's an open source foundation. So that's all about the code. Once that code gets released, once the base code, I hope all of you guys out there that are writing code are doing pull requests. It's all about the code talks at that point. These consortia, some of them are well run, some of them are not. The worst of them, as we all know, are ones that just kind of sit around and talk it out all day long and never get anything done. I don't see that happening with R3. They're clearly an action-oriented team.
So there was a earlier perspective at the event and talk about, does blockchain actually offer the value for financial institutions, or is this kind of just a hype, right? Is it really going to be so significant that it will add more value beyond the incremental things? How would you respond to that kind of purist kind of perspective based on your interactions with the customers, right? Obviously, there are 42 or 40 banks involved in R3. There are also other banks involving Linux Foundation. Banks themselves are doing things behind their doors. I mean, how would you respond to that for the audience?
I think for us, it's to be seen, whether it's incremental or transformational change. And a lot of that depends on how it's deployed and what gets adoption. And I think to some extent, what the financial service industry is doing, and this was talked about by Luis earlier, is they are trying to somewhat cannibalize and disrupt themselves, because I think moving more towards more incremental change may prevent them from that sort of transformational disruption that some of the startups are going after.
So who here uses Flywheel in the audience? Yeah. Who uses Uber? Yeah, okay. So the taxi industry, I started Flywheel. And the taxi industry back in 2008, we thought, hey, let's improve it. Let's radically improve the taxi industry before it disrupts itself or gets disrupted. And you know what? The taxi fleet owners hadn't read Christensen, right? So, but bank executives have. So I think that the opportunity for disruption, as opposed to radical improvement, is more of a question mark in this industry, because the executives, they know that, they studied in their innovator's dilemma, and they know that they better get in front of this or they will get disrupted. And what we're seeing is that there's a lot more immediate opportunity for what I would call radical improvement. And sometimes a change in degree can be a change in kind if it goes far enough. But you can really radically improve a lot of these systems without going all the way to trustlessness, to permissionlessness.
So give us an example on that. Some of the immediate examples or opportunities that you're seeing and clients are coming to IBM, asking them to use blockchain to potentially solve or
Sure.
experiment on.
I'll give one that's my favorite example, and it has nothing to do with finance at all. Is that okay?
Yep.
All right, but I think you get the idea from this. So we don't see blockchain as a financial instrument technology so much as we see it as a transformation of the internet itself. It's the internet evolving. Would you agree?
Yeah.
Yeah, it's becoming transactionally aware. And insofar, and that takes us to what my favorite story, which I call my uncle's story. My uncle supplies the automotive industry, plastic parts in Michigan, right? And these parts, all of the machines that make stuff that go into OEMs, into cars today, are made by machines that have telemetry ports on them, right? Now, say a car crash happens, Ford gets in a crash, people die, NTSB comes and investigates the car crash and finds that this is the part that failed. It's my uncle's part. And he's watching CNN, he sees this. And you know where that data goes right now? You know where that data from the telemetry port goes? Into a CSV file on a laptop, right? So what do I do if I'm, no, my uncle's a good guy, but say I wasn't so ethical, right? Start changing some data, right? So that's my first problem. Second, but that could be solved by Ford just making all of the suppliers put their telemetry data into a big Ford database, right? Could do that. Why don't they? Well, because my uncle would never he would go kicking and screaming into letting his data, his speeds and feeds, be seen directly by the OEMer. And he certainly doesn't want his competitors seeing it. And the big problem is, and this is the pattern we look for, if Ford did it, GM wouldn't participate in it. If GM ran it, Ford wouldn't participate in it, right? It has to be, and this is where a blockchain, a business network based on blockchain pattern could be really useful, because I can say, no, it's the internet, stupid. You all have it. Everyone has control, but no one is in control. There is no central control system, and it's distributed trust. So we talk about permissionless, we talk about permissioned, we talk about private, we talk about public. I like the idea of distributed trust, right? You don't have Visa on one side and Bitcoin on the other. In the middle is massively distributed trust, which I think we share that point of view, right? I think that's the basis of your cool stuff. So, so now the NTSB could go into a blockchain, and it looks like a centralized system, but it's distributed, right? So I don't have a politics problem, but I have a singleton. I don't have to jack into, and everybody's API is going into everybody's system of record. I just jack into this one chain. And now I've got my multisig, I'm the NTSB, and I say, oh, this part was made during a 15-minute window when 50 parts were made, and 30 of them went into GM cars. That went from a 1 million car recall to a 50 car recall. That would be a good day for us all. And then from there, lots of other things can happen. You can get into trade finance, supply chain. You can get bills of lading. All sorts of stuff can go on that same chain, and you have this massive virality outwards and vertically. And we think that's pretty cool. So we think of it as a way of creating viral business networks with a lot less energy required to start them.
Yeah, I think for us, we do see this sort of evolution of the internet. So I think with the internet, we had this permissionless sharing of information. So anyone could start up a blog, and you didn't have to be the New York Times, right? You could get your voice out there. I think we're seeing something similar with value today. And so with Bitcoin, you obviously have this token that transfers across the network, transfers value, but it can't be copied. And that's really the innovation that we see. And we think that this notion of digital scarcity, as well as provenance and some of the things that John talked about, are where a lot of the really interesting use cases can come from. And that could be as simple as concert tickets, right? We could be passing concert tickets across on the blockchain. You're eliminating folks like Ticketmaster or StubHub or what have you. And we think that those really, really simple use cases are where we'll actually see some explosive growth.
So earlier when you talk about building the fabric and starting that fabric, just for the audience here, what does that exactly mean? What are some of the key components of the fabric that you guys are focused on in HyperLedger as kind of the first order business that you have to tackle that before you can build other things on top of the fabric?
Yeah, so I think both the Intel and the IBM architecture are similar in that there's really three main layers that we see the fabric. The lowest layer is the networking layer. This is how do the nodes talk to each other? How do they find peers? The second layer is the journaling layer. That's really where you get an ordering of transactions, and that's what prevents things like double spending and what have you. Part of that journaling layer is consensus. So there's a number of different ways that you can do consensus and arrive at an agreed upon state of the network between the peers. And then the third layer is this sort of business logic layer. And for instance, with Bitcoin, those three things are all sort of crammed into one. With a network like Ethereum, you can have multiple types of business logic and multiple contracts, or smart contracts as they're called, that are performing different operations all on the same underlying fabric. And so those are really the three categories that we're looking at, and we think certainly the sort of first and second layer are the ones that are most ripe for some sort of standardization.
I agree with that. I mean, the ordering part, of course, is the first step in anti-double spend. Then you have to have logic that covers it later, which you could do in a variety of things, like we're supporting like a UTXO model on the HyperLedger, what we call chain code method. But the one that I'm particularly interested myself is on that logic layer, but with confidentiality. So if I'm trading donuts and cookies with you, and I have an agreement that if you give me 4 donuts, I'll give you 3 cookies. But if you give me 4 donuts within 3 days, I'll give you 4 cookies, right? That's great. I could write that in assembly today, but the problem is if I control the code, I could jip you out of a lot of cookies, and hence we don't have as much automation about how businesses, especially businesses in particular, manage their obligations to one another. We have a lot of people on phones and email making these things happen. Well, now I can write this on something like Ethereum, and it's immutable, right? And I know that unless we change it mutually, this is going to happen. So now I can trust that code, and I can run it. Now, the problem is in a public network like Ethereum, the cookie donuts business is really small, and you and I are also trading cookies for donuts. And while it may not be that you can directly see, you can't see, that it's this identity, you kind of know who I'm trading with. And you know that I'm giving him 2 more cookies than you. Because because everybody gets to execute the code. Every node executes all the code. And we're like, that's a terrible idea. We can't have that if we're going to start building business networks with almost all business-to-business contracts are confidential. So you have to have an idea of confidentiality. And that's an incredibly hard problem. And with all the existing fabrics focused so hard on things like proof of work, which is an incredibly hard problem, you spend all your energy thinking about that and not about something like confidentiality. Hence HyperLedger. We really wanted to focus HyperLedger on things like that.
And what's the timeline, HyperLedger? What's coming out in 1 half or second half?
Oh, I think we can say
yeah, so I think the thing that's planned as our next step is we have a sprint that will be happening sometime towards the end of this month, where we're hoping to get a number of the participants on as the broader community as well as the technical steering committee together to sort of start sussing out where are the common building blocks that we need to standardize on.
Maybe open up for questions to the audience. Gentleman in the front and then gentleman in the back. Go ahead, sir.
So I have a question. So for Bitcoin network, why the miners they keep mining Bitcoin? Because they have the blocker reward. Yeah. So for HyperLedger, you do not have the blocker reward for the people who maintain the network. So what's the motivation for them to keep maintain your HyperLedger network?
Yeah, I think, so incentives, we think, is a very important piece of permissionless blockchains. For permission blockchains, the incentives are really extrinsic to the system. So if I'm JP Morgan and I'm trading on a blockchain, I'm gonna run a node, I'm gonna run 5 nodes or 10 nodes because that's my data, right? And that's my business. So in those cases, it's external to the system. We think intrinsic rewards are something that's interesting as well. And we'll probably see some of the importance of that over the next 4 to 10 years on Bitcoin as the reward lowers. And so I think that there's a lot of research that needs to go into how do you incentivize folks to run these networks, right, if there aren't extrinsic rewards.
Yeah, I think what's your reward for running a web server, right? So that the question is, if this is a transformation of the internet and you've got to be running a peer to be doing business on the transaction web, as long as you're not having to pull down an Ireland's worth of power to solve crypto puzzles in order to generate artificial scarcity on a token called Bitcoin, I think your expense for doing for being part of this is low enough that the advantage, at the most basic level, the advantage is that you're conducting business, and you're part of the conducting of business. And so if you want to be part of it, you've got to do a little work, but it's not like mining. So that would be one. Now that's, remember, HyperLedger is not defining a token. There is no Bitcoin in HyperLedger, right? So you would define that as a piece of chain code. You would create an asset and you would say this needs to be anti-double spent. And that could be on one chain over here, and there could be another chain over here doing something entirely different. And that's actually interop becomes the interesting problem there. So we don't believe that there's going to be one chain to rule them all.
Gentleman in the back, over here.
So, well, two things. I mean, on one side, having studied economics, I worry about I worry about economics being at the foundation of this is why you're not going to do bad things argument, right? So, hey, you could do bad things on certain networks we all talk about, but you won't because it's against your enlightened self-interest. I'm like, one word comes to mind: ISIS, right? I mean, bad thing. People do bad things for all sorts of irrational reasons, and I have to wonder, if there's a bunch of mining groups in countries that have low power costs, they're not calling each other really. They're not. I just worry about that. What I like much better is known entities, lots of them, especially with the Intel approach. Lots and lots of known entities where you're knowable. You're part of a very large distributed trust network. And then you deal with the bad acting that way because you're all naked in a glass house. I know almost instantly, even in the cases of things like censorship, which is the hardest one to control for, right? If I can all collude to prevent a transaction from ever existing. Yeah, that's the hardest one. But if you're out there in the open, right, you're naked in a glass house, then we can catch you almost instantly, right? So there are two ways to, there's. And then we do a lot of work in cognitive, as you know, and so doing a lot of real-time analytics on these networks is another way to deal with that.
Yeah, I would also say, just to follow that up, I think for the permissionless settings, I think Byzantine fault tolerance is something that's required in the consensus mechanism. And quite honestly, I think it's also something, an additional layer of security that should be in most of the permission settings as well. And I think that's why you're seeing that anyone who's going to transact on that network wants the ability to put transactions into the network, wants to be a validator so that they can prevent some of these things like censorship of their transactions. And so I think it's important that if you want to have your transactions in that network, you're probably going to want to have either a business relationship with someone who is performing validation of the transactions or be a validator yourself.
3 more questions. So lady and gentleman, and then over there.
Can you compare and contrast how Multisig is implemented on the HyperLedger and the Intel platforms?
Yeah, so I think in Multisig, the question was how does Multisig differ on Intel versus HyperLedger or on the open blockchain platform? To be honest, I don't know how Multisig is implemented on the IBM one. For us, that's it's more of an implementation question. I don't think that we've really achieved any sort of standards. I think today we're using similar curves. Today, at least for us, we're using the Bitcoin elliptic curve. But I don't think that's too big of a concern for us. I don't know if you have any comments on it.
Yeah, no, you implement it in what we call chain code, and it's pretty straightforward. So, and by the way, you can go and get it. It's on open. It's on GitHub right now, so you can go and look. How a multisig works? Well, yeah. So you would define in chain code. You define the asset, and then if you're gonna run a bunch of different counterparties, then you have to you write that into the logic of the code of that asset.
Yeah, I think there's multiple ways to implement it. You can either just say, hey, two of these, you need a signature from two of these public keys. That's one way. There's also things like threshold signatures and ring signatures, which are other cryptographic techniques to implement it.
A question about intellectual property. So you guys are both working in the open area, like HyperLedger, but also the consortiums, and then you're also companies are in the business of selling services and technology yourselves. How are you guys balancing sort of that intellectual property? What do you give up? What do you keep? What do you?
Yeah, I think for us, it's always been pretty clear for us about what needs to be open, and for us, it's about where can we differentiate. And so on some of these core things like the networking topology, right? Those things are not novel, they're not necessarily new, and so they shouldn't be something that everyone should be re-implementing. And so that's sort of how we've determined what we think is open versus what is something that's a potential business offering, is there a sustainable competitive advantage here? Is there an ability to differentiate?
Yeah, same here. We've been doing open source for like forever, and you look at the internet, you say, well, people made a few nickels on the internet, but you don't have to actually own the code there, right? So we're talking about going up the stack and where we have a right to play, in a variety of interesting problem areas that we can instrument on blockchain. That's where we'll go, and of course, yeah, we want you to run your nodes on SoftLayer, and we want you to have us do your systems integrations of that, and that's a big deal right now. In fact, what we found out a few weeks ago doing some research is that way more companies want to integrate their systems of record into a blockchain Rails sooner than we ever anticipated. So we're actually doubling down now on system integration.
One more question.
My question is that as we're working with different financial companies as well as technology companies on the HyperLedger project, are you experiencing more reluctance towards this disruption or more openness because people are realizing that this is imminent and it's going to happen? What's your experience?
I think it's all been collaborative, at least from my experience. I think that everyone's in a sort of stage of experimentation right now. So I haven't really noticed any contention between tech providers or the banking participants or those that are looking at this from industrial monitoring and supply chain and other uses. So we haven't seen anything. And I think part of that's the nature of an open source Linux foundation. So for us, it hasn't been any sort of issue.
Yeah, I mean, people are going to duke it out above the fabric, and that'll be fun to watch. Right, we're all going to go at it. My first job at IBM was on Java, and I was actually next door to Sun in Cupertino, my first office, and we duked it out a lot on all sorts of levels. But when it came to getting Java right, we were besties, and I think that's what we're seeing right now. So it's kind of very collaborative right now. And then once we get this locked down, and then that will go on a pace, and people will start to say, oh no, you really need my platform for this, and no, those guys are suck. You need my platform, and that'll be fun. That's how it's supposed to work.
Which is how the cloud has been, right? Just overall, the concept of cloud has been like that.
I mean, from what Thomson Reuters is looking at, this is moving much faster in terms of much faster for financial services, for other industries.
30 years, I've never seen anything go this fast, ever.
Faster. So, should we wrap up? Yeah, okay. Well, more questions over networking. So thanks so much, John and Kelly.
Thank you.